So, all right, we're going to start chapter 8, which we're going to talk about different kinds of variation. So we've got direct variation and we've got inverse variation. Two totally different equations today, okay? So the first equation, direct variation, starts out with a y equals kx. The easier way to think of it instead of k, the book likes to use k. The book does. I like m because it's really like a slope. So if you think about y equals mx, then it's a little bit easier. Must always go through the origin, okay? So let's do example 1, and then I'll talk about the inverse variation, okay? So example 1 says it varies directly. So I know if it's directly, it's got to be a direct variation, right? So if we write our y equals kx, it first says let's graph it. So if y is 14, so if I go by 2, it's probably 2, 4, 6, 8, 10, 12, 14. If I go by, I can even go by ones here. I could go 1, 2, 3. I can go by 1, 2, 3, 4. So if I have a 3.5 and a 14, I could put a point right there, okay? Because I know it's a direct variation, I know there's one other point. Has to be 0, 0. Direct variation always goes to the origin. So I have 2 points. I got the point 3.5, 14, and I have the point 0, 0 because it always goes through the origin. So then I can go ahead and connect the points. Okay, so here's my line. Now, I've got it graphed, but if I want to find the value of k, I'm just going to plug things in. I'll put 14 there. I'll put 3.5 there, and I'll solve for k. So I'll go, okay, 14 is equal to k times 3.5, right? I just plugged them in. There's my y value. There's my x value. I need to solve for k now. So to solve for k, I'm going to divide by 3.5, divide by 3.5, and I think it's 4, but I'll double check my calculator. Yeah, it's 4. So I get k equals 4. Okay, so first step I always do is I find the value of k first. So to find the value of k, I plug stuff in, solve for k. And the second thing I do is I rewrite the equation. So the equation for this one is simply going to be y equals 4x. That's my equation, okay? Now, let's look at number 2. So example 2 talks about inverse variation. So we saw those graphs, or these kind of weird looking loopy graphs. We saw that on the reading, right? Yeah, you're going to have those weird little loopy graphs, right, with asymptotes. So example 2 says y varies inversely with x. We can write this as y equals some kx, or we could write it as xy equals k, but it's easier to write it this way. Same equation, it's just one is solved for y and one is not solved for y. So let's go ahead. If y is 3 and x is 2, I have a point there, okay? So that's enough to be able to find k. So if I want to find k, I can plug both y and x into, plug it into that one, x, y equals k. So if x is 2, y is 3, then k is 6, right? Yeah, I just multiply. That's all I did. That's all I did. We could do that too. So if I use this equation, we're going to have our 3 equals k over 2, right? If you want to use that one, Grace. They're the same equation. How would you solve for k right here? Wouldn't you multiply up 2 by 2 anyway? That's what I got. Okay, that's what I got. So the equation, either it's going to be x, y equals 6, or you could say y equals 6 over x, right? They're the same equation, same exact equation. This one, the reason I like to put it this way is because you can actually put it in the calculator. You can graph this on the calculator. I'll show you real quickly. If you go y equals, clear, clear. Oh, I got all sorts of stuff going on in this calculator. Okay, let me get my other calculator. It has less mess on it. All right. Well, quit. Can't divide by 0, right? So clear. Let's just go y equals, clear that. And if I go 6 divided by x, let's see what it looks like, okay? There it is, just like we've been doing, right? And one thing again I notice is this line gets comes down, it gets closer and closer to 0, but it never gets there, right? This line goes up and up and up, but never gets there, right? So same thing. Now, it won't draw in the asymptotes, because the asymptotes are not part of the graph. They're just invisible borderlines, okay? So we know that if you're going to make 6, 3, and 2, 2 and 3, right? 6 and 1, 1, 2, 3, 4, 5, 6 and 1, and 1 and 1, 2, 3, 4, 5, 6. Okay, there's 1/2 of my graph. And you've got the negatives as well. You've got -3, -2, -2, -3, -6, 1, 2, 3, 4, 5, 6, and -1, -1, and -6. And we get this graph right here. Okay? All right? It does have asymptotes. I like to put them in because they're not part of the graph per se, but they're the boundary lines the asymptotes are, okay? They're the boundary lines. These are my asymptotes.
You just like saying asymptotes.
Say it again.
You just like saying asymptotes.
It's a cool word, isn't it? Asymptote. Okay, now example 3. You ready to do example 3? No, not yet. So inverse. It's going to have this shape, always, right? Directly variation is going to be a straight line going through the origin. Always. Example 3. Let's read it. The area of a triangle varies jointly. Okay, jointly means we're going to have a couple of different things going on. With the base B and height H. Okay. So I'm going to go, okay, area is equal to K. Got to have K. You've got to have that in there always. And I've got jointly varies with B and H, so B times H, right? So, yeah, and then what I need to do is I already know K. K has to be 1/2. It has to be, because think about the area of a triangle, 1/2 base times height. But let's prove it's 1/2. So if we want to find out what K is, let's plug in what we know. If the area is 12, when the base is 6 and the height is 4, we can plug in the 12 for the area, the 6 for the base, and the 4 for the H. Then we should be able to solve for K. So I get 12 equals K times 24, right? If I solve, I'm going to divide by 24. Divide by 24, and I get 12 over 24, which is 1/2. I kind of knew that was going to be the answer because I know the area of a triangle is 1/2 base times height. So instead of K, let's just write what it is, which is 1/2. So that is the area of a triangle, right? Great. We already knew that, but now we just proved it. So if we know the formula, let's use the formula. So now the next thing says, okay, well, find B now when A is 36. Let's put 36 right there. And H is 8. Let's put 8 there, and we'll solve for B, okay? All right, I can do that. Put my 36 for the area. I don't know the base, but I know the height is 8, okay? And so I've got enough information in there to figure out what the base is. First, half of 8, that's easy. Half of 8 is 4, right? So I got 36 equals 4b. Divide by 4, the base has to be 9, okay? So here's what we always do. First thing we do is we figure out whether it's a direct variation or inverse variation, always, or if it's joint. And we set up some kind of equation, right, with K. And then once we set up the equation with K, we solve for K so we can get the equation. Once we find out what K is, we just rewrite the equation and then we use it, okay? Those are always going to be the steps. Okay, return the page. Okay, turn the page. Now, example 2. How do I know which one it is? Well, first of all, this first one cannot be inverse because this times this is what? What's this times this? What's 3 times 9?
27.
Is 8 times 24 going to be 27? So I mean, it's supposed to be this times this equals the same number of times. So this one cannot be direct variation. So this one's got to be my direct variation, not my inverse. But let's check out what the slope is, which is the same thing as K. 9 over? Yes. 9 over 3, right? Or 24 over 8, or 30 over 10. Yeah, they'd have the same K value every time, wouldn't they? So if they have the same K value, it's got to be in the form of y equals 3x, which makes it, this one's going to be a direct variation. All right. Now, on this one, these are not going to make the same slope. 18 over 2, 3 over 12. So there's no way this one's direct variation. But I know that 4.5 times 8. Well, what is 4.5 times 8? I don't know. 4.5 times 8. 36. 12 times 3? 2 times 18? So if I got x times y, if I have x times y equals 36, every time, it's got to be my inverse variation. This has got to be my inverse. So its equation would have to be x, y equals 36, because the two numbers multiply by 36, okay? Not that bad, is it? So here's how I can tell. Easiest way to tell if it's inverse is these two and these two. If you multiply this times this, or this times this, or this times this, will always make the same number. Okay? On this one, the slope, which is k, has always got to be the same, okay? And that's how I know if it's direct variation. Example 5. So example 5's got a lot of stuff in it, but let's read it carefully. Okay, the time t that it takes for a group of volunteers, let's call that v, okay, to construct a house varies inversely. So I'm going to set up t is equal to k over v. I'm going to start there, inversely, okay? Inversely. I'm going to go y equals k over t, okay? And that's in our reading. Remember, if it's inverse variation, we could use either one of these, but since we're using a variable, let's just use that one, okay? Now, let's find out what k is. So we get some more information. If we have 20 volunteers, I'll put 20 here, and 62.5, that's time in hours. I'll put that there. We should be able to solve for k. So let's put our 62.5. That's a time in for time. 62.5. K over 20 volunteers. So that's v, right? And then to solve for k, that's easy. I'll just multiply it up, right? I think it's 1,250, but I'll double check. 62.5 times 20 is, yeah, what do you know? 1,250 equals k. All right, let's look at the board. So on the board it says first, figure out which one you want. So we wanted to use the inverse variation, right? Second thing we did, so we found k. We found k. We got k, right? And now let's rewrite it. So my equation is going to be, all right, let's go back up here to t's and k's. We're going to rewrite this as t equals 1,250 over v, okay? Now I've got my equation. Let's use the equation. So there's more information. So now we're saying, okay, how many hours would need to take a build? Oh, how many volunteers? How many people? How many volunteers? So 50 hours. 50's got to go there, right? For time. So we'll put our 50 in for time equals our 1,250 over v. And let's solve for v. Okay, what do we do to solve for v? I will divide by 50, yes, but I'm going to show that. You're totally right, Will. If I first bring up the v, I'll have a 50. V equals 1,250, right? And then I'll divide by 50. You're totally right, Will. So v is equal to 1,250 divided by 50. And what's that answer? I don't know. Divided by 50. I get 25. So I'll need 25 volunteers. Okay. All right. Let me go ahead and press